Hello everyone, this is Dr. Nak and we're going to go over section 8.4 Trig Identities. So this section, you're either going to love it or like it at least, or hate it. And I really want you to like it, but in order to like this, or I should say become one with the proving identities, you're going to have to memorize all the identities that you have learned so far. So here are some of the basic identities that you have learned so far: Pythagorean identities, fundamental identities, and even and odd identities. Now, in order to prove trig identities, always start with either right-hand side or the left-hand side. And usually you might want to pick the more complicated expression. And another trick would be, if you're given two fractions, combine into one fraction. And another trick is try to rewrite one side in terms of sines and cosines. And always keep the goal in mind. Goal meaning what you're trying to prove. So let's start doing a bunch of examples. Example 1, establish each identity. We have secant of theta times sine of theta equals tan of theta. So in order to do this, you want to pick either, if you want to start from the left or the right. Pick the most complicated looking one. So I'm going to start out with the left hand side. So let me just start out here. And I'm just going to write it as left hand side equals. Alright, so let's get started. Always write down the given problem. Okay, now keep in mind your goal is to simplify this so that you're going to get tangent of theta for the answer. Okay, so trick is to convert everything in terms of sine and cosine. So what I'm going to do for this particular example is secant is 1 over cosine. And I'm just going to keep the sine of theta. Okay, but this is same thing as what? Sine of theta over cosine of theta. Now, this is nothing but tangent of theta, which is the right-hand side. Okay, and in order to do a proof, you're going to have to show every single step. Let's try another one. So let's call this one example 2. Sine of theta and times cotangent of theta plus tan of theta equals secant of theta. Okay, so which side do you want to start? I would start with the left hand side because that looks a little bit more complicated. So let me underline that. Okay, so let's start. Oops. Left hand side equals, let me just copy and paste the problem. Okay, so what should we do? There are many ways that you can prove this, but you're gonna have to show every single step. So first, how about distributing the sine of theta? So then here we're gonna get sine theta cotangent of theta plus sine of theta, and then tangent of theta. So somehow we're going to have to prove that this whole quantity is going to equal to secant of theta. Okay, so let's see. How about this? Let's use the trick of converting everything in terms of sines and cosine just to see where it's going to take us. And if that fails, we'll just cry together and try something else. Alright, so this is same thing as sine of theta. Now cotangent is cosine of theta over sine of theta plus sine of theta, and tangent is sine over cosine. Okay, now let's see what we're going to get. So let's see. We could cancel out the sine of theta and we could write this as cosine of theta plus, now you have a sine of theta times sine of theta, so that becomes sine square of theta over the cosine of theta. Now what, right? So since we're given two fractions, so let's try to combine this two fractions into one fraction by getting the same common denominator. Common denominator is cosine of theta. So what I'm going to do is I'm going to multiply the left-hand side by cosine of theta over cosine of theta. So if we do that, what do we get here? Cosine theta times cosine theta is cosine square of theta over cosine of theta plus sine square of theta over cosine of theta. Okay, now let's combine. Then you're going to have cosine of theta on top, cosine square of theta plus sine square of theta. Okay, now what? The numerator, sine square plus cosine square equals to 1 by the Pythagorean identity. So we're going to use that. So here what we're going to get is 1 over cosine of theta. And what's 1 over cosine? That will be secant of theta. So, whoops. Okay, is this what we wanted to prove? Yes, it is. So this is the right-hand side. And we have established the identity. Okay, let's do another example. Example 3. Quantity cosecant theta plus cotangent of theta times the quantity cosecant minus cotangent equals to 1. So clearly, I would start from the left-hand side. Okay, so copy and paste the problem. I know it's pain in the butt, but just do it. Okay, so what would you do? I kind of want to multiply this out, so let's try that. So if I multiply this out, we're going to get cosecant square of theta, and then minus cosecant of theta, cotangent of theta, plus cotangent of theta, cosecant, and then minus cotangent square of theta. Okay, now let's see. We can cancel these two out. So here we're going to have cosecant square of theta and then minus cotangent square of theta. Okay, so now remember this identity, the Pythagorean identity involving cosecant and cotangent was what? Cotangent square of theta plus 1 equals cosecant square of theta. So if I subtract cotangent square of theta from both sides, then do you see that we're going to get 1 back? So let me just write everything out. So that implies that cosecant square of theta minus cotan of square of theta equals to 1. All right, so that's exactly the expression that we have here. So therefore, this is going to equal to 1 by the Pythagorean identities. So this is exactly what we wanted to prove. So we're done. Okay, next example. So let's try cosecant fourth of theta minus cosecant square of theta equals cotan of fourth of theta plus cotangent square of theta. All right, so let's try this one. Now, left-hand side and the right-hand side, they're both equivalently difficult. So pick either one of the sides. So since we have been picking left-hand side, I'm going to show you that you don't have to always pick the left-hand side. So what I'm going to do is I'm going to take the right-hand side this time. Okay, so let's start. Right-hand side equals, okay, now let's write down the problem. Right-hand side is cotangent fourth of theta plus cotangent square of theta. Now feel free to pause the video and let's see if we can do this problem or not. Okay, but anyways, so what I would do for this is I'll I can factor out the cotangent squared. So let's see where that's going to take us. So we got cotangent square of theta, and you're going to have cotangent square of theta plus 1. Okay, now let's take a look at a little bit more closer. Now cotangent square of theta and cotangent square of plus 1, I believe that's going to be what? Cosecant square of theta. But let me just write down everything out. So let me just go over here. So note that cotangent square of theta plus 1 equals cosecant square of theta. And then that implies that cotangent square of theta is same thing as cosecant square of theta minus 1. So what I'm going to do is I'm going to use cotangent square equals to 1. Oh, sorry, cotangent square plus 1 equals cosecant squared. So that will be this guy right here. So this is going to become cosecant square of theta. And then let's take a look at this one right here. Now cotangent square of theta is cosecant squared minus 1. So let me just give myself a little more room. Oops. Okay, so now let's see what's going to happen. So what do we get? What are we trying to prove again? So let me see. I want to prove that this is going to be cosecant fourth of theta minus cosecant square of theta. All right, so I think we got it. So distribute the cosecant square of theta. Then we're going to have cosecant fourth of theta minus cosecant square of theta. What I just did was I just multiplied like that. Okay, so this is precisely our left-hand side. So we have proved the identity. Okay, let's do another example. Cosecant minus cotangent equals sine over 1 plus cosine. So what I'm going to do is, let's pick the right-hand side. I'm going to pick the right-hand side, but feel free to pick the left-hand side if you like. So let me just underline which side that I'm going to pick. Okay, and then here I'm just going to start out with the right-hand side. Copy and paste the problem. Okay, so now let's look at this a little bit. The common trick to problems like this is to multiply by the conjugate of the denominator. So let's try that, and if that fails, we'll try something else. So here, multiply by the conjugate, which will be 1 minus cosine. Okay, so then what do we get? We're gonna have, let me see, sine of theta minus sine theta cosine of theta, whole thing over. Now if I multiply that out, I'm going to get what? 1 minus cosine square of theta. Okay, so now let's see what's going to happen here. Now remember the Pythagorean identity. Sine square of theta plus cosine square of theta equals to 1. So 1 minus cosine of theta is going to give us sine squared. So if you want me to rewrite everything, so that implies that 1 minus cosine square will give us sine squared. So let's replace the denominator with sine square of theta. Okay, so this is what, sine squared, sorry about that. Now let's stare at this for a little bit. Okay, so it looks like we have something of the form a minus b over c. So remember this property, you can separate the numerator into a over c minus the b over c. We use this trick quite a bit, so let's just apply that and see what's going to happen. So here you're going to have sine of theta over sine squared. and minus sine cosine, whole thing over sine squared. Okay, so let's see what we're trying to prove. Okay, we want to show that this is cosecant minus the cotangent. Oh, I think we got this. So we could cancel one of the factor of sine of theta from here. So if I did that, if I divide this guy by sine of theta, divide this guy by sine of theta, then I'm going to have just 1 over sine of theta left. And then minus, this is same thing as sine of theta over sine square of theta. So you're still going to have sine of theta alone by on the bottom by canceling out one of the terms of sine. And then on the top, you're going to have a cosine of theta. So what's 1 over sine? That's cosecant. Minus, now cosine over sine is cotangent. All right, I believe this is what we wanted to prove. So this is our left-hand side. So we're done with the problem. How you all doing? Are you kind of getting hang of it? I hope you're liking it up to here. Next example. As you see right there, which side is more complicated? I believe the left-hand side. So I'm going to start working from the left-hand side. So let me copy and paste. All right, so what do we do here? Since we're given two fractions, let's try to combine this into a one fraction by getting the common denominator. So the common denominator is what? Common denominator is cosine of theta times 1 plus sine of theta. Okay, so that means what? I need to multiply this by cosine of theta and cosine of theta, and I need to multiply this by 1 plus sine of theta and 1 plus sine of theta. Okay, so let's combine this into a one fraction. So it looks like we're gonna have cosine of theta times the cosine of theta, whole thing over 1 plus sine of theta times the cosine of theta, and then 1 plus sine of theta, 1 plus sine of theta. Okay, so did I copy this right? Okay, so let's keep going. So what do we get here? So let's just simplify a little bit. So first, we're going to have cosine square of theta plus, now if I multiply 1 plus sine of theta times 1 plus sine of theta, what we're going to get is 1 plus 2 sine of theta plus sine square of theta. And then we still have on the denominator 1 plus sine of theta, multiplying here by the cosine of theta. Okay, so what are we trying to prove again? Oh, this is going to equal to 2 secant of theta. Okay, we're a little bit far off. Okay, so what do you see? I see sine squared plus cosine squared. So remember, addition is commutative and associative. So you can rewrite this as cosine square of theta plus sine square of theta plus 1 plus 2 sine of theta, whole thing over 1 plus sine of theta, and then cosine of theta. Okay, now cosine squared plus sine squared is 1. So here what we're going to get is, 1, then plus 1 plus 2 sine of theta, whole thing over 1 plus sine theta, cosine theta. Okay, so now what? Can we also have, maybe we can add 1 and 1 together to get, sorry, I meant to color code this into blue. So now what do we have? 2 plus 2 sine of theta, whole thing over 1 plus sine of theta, and then cosine of theta. Okay, so maybe, I see. Let's factor the 2 out from the numerator. So you're going to have 2 times 1 plus sine of theta, whole thing over 1 plus sine of theta, and cosine of theta. Okay, so we can cancel 1 plus sine of theta. So what do we get here? So we have 2 over cosine of theta, which is what? This is same thing as 2 times 1 over cosine of theta. So this is 2, 1 over cosine is secant. Whew. So that is our right hand side. So we're done. All right, now let's increase the level of difficulty a little bit. I mean, I don't mean difficult. All I mean is that maybe the proof is going to get a little bit longer than the past examples. So in this case, I will certainly take the left-hand side of it. All right, so let's start out with left-hand side equals. Okay, so what I did was I just rewrote the problem. Okay, so let's just look at this a little bit. Maybe I could multiply by the conjugate of the denominator, but I still have a 2 cosine square of theta left. So how about this? Let's try to convert everything in terms of sines and cosines, and let's see where that's gonna take us. And if we get stuck, then we'll just erase that whole thing, and then we'll just cry together, and we'll try something else. So first, tangent is sine over cosine. Cotangent is cosine over sine. And whole thing by oops. I hope you caught my mistake here. That should be a minus. Sorry about that. And plus 2 cosine square of theta. Okay, so the next step, what I want to do is let's combine the numerator into a 1 fraction. Then let's combine the denominator into a 1 fraction. So the common denominator will be sine times cosine. So let me multiply this guy by sine over sine. And then here, cosine over cosine. And let's do the same thing. All right, so what do we got? So we have sine of theta times sine of theta, which will give us sine square of theta, minus cosine times cosine, cosine square of theta, whole thing over sine cosine. So that was just combining the numerator, and whole thing dividing by sine square of theta plus cosine squared, and all over sine cosine. And this little plus 2 cosine square of theta. All right, so now let's look at that ugly fraction a little bit. So do you remember this property? A over B over C over D. This is what? A over B multiplying here by D over C. So that's exactly how we're going to simplify that ugly looking fraction. All right, so don't worry, I'll write everything out. Sine square of theta minus cosine squared, all over sine cosine, multiplying here by the reciprocal of the denominator, And don't forget this little plus 2 cosine square of theta. Alrighty, so far so good. Now what can we do? Maybe we can cancel out the sine cosines. I think that's a fantastic idea. So then what do we have left over here? So we got sine squared minus cosine squared, and all over sine squared plus cosine squared. Oh look, that's going to turn into 1 by the Pythagorean identity, and then here you're going to have plus 2 cosine square of theta. Alrighty then, so sine squared plus cosine squared is 1. So here, let's see what we get. Sine square of theta minus cosine square of theta all over 1 plus 2 cosine square of theta. Alright, what the heck were we trying to prove again? Oh my goodness, we're trying to prove that this whole ugliness is going to equal to 1. Alright, let's keep going then. Okay, so now, since this is over 1, what we're going to get here is sine square of theta minus cosine square of theta plus 2 cosine square of theta. Okay, looking good, because look, I could combine these two, right? So remember, there is an invisible 1 sitting here. So we have minus 1 cosine squared plus 2 cosine squared. That will just give us 1 cosine square of theta. Okay, so this is sine square of theta and minus, or I could do plus. You're gonna have, you know what, let me just, I don't want to lose you by you asking me, what the heck are you doing? So you know what, let me try to rewrite this so you'll see it better. So this is sine square of theta plus 2 cosine square of theta, and then minus cosine square of theta. Alright, so I just rewrote it. So let's take a look. So over here, what I can do is combine these together. So here you're going to have sine square of theta, and then plus 2 cosine squared minus 1 cosine squared would give us 1 cosine squared. I hope you got that, because look, a lot of students ask me this. So suppose you have 2x minus x. Pretend x is the cosine squared. So isn't this just x? So that's exactly what we did. Instead of a x, we had the cosine squared. But anyways, sine squared cosine squared is 1. Alright, so I think we are done. So this is the right hand side. So it worked. Okay, do not get discouraged. You're probably going to ask me, well, how do you know what to do? You will figure it out what to do by practicing problems after problems after problems. So you can do it. So let's do another one. I promise this will be the last example that we're going to go through. And those of you who watched this whole entire thing, great job. And I hope you're starting to like it a little bit. I know that this gets really frustrating, but keep practicing it. You can do this. All right, so let's try this problem. And obviously, we're going to start from the left-hand side. Alright, so what I did was I just rewrote the problem. Okay, so let's see where we can go with this. So first, let me just work it step by step by step. So secant minus tan whole quantity squared means what? Secant of theta minus tan of theta, and multiply by secant of theta minus tan of theta, and then plus 1, and whole thing over cosecant of theta, and then what should we do over there? let's just leave it alone. All right, so then here you're going to get cosecant of theta and secant theta minus tan of theta. Okay, so now let's try to multiply out the numerator. So here what do you get? Secant square of theta, and then minus 2 secant of theta, tan of theta, and then plus tan squared, and then plus 1, whole thing over cosecant and secant minus tan. Sorry about that. That was a minus in between. All right, so let's just stop for a little bit. What can we do? What can we do? All right, so how about this? Maybe we can use the fact that tangent squared plus 1 will give us secant squared. All right, so let me try it that way. So this is secant squared of theta. Okay, so then we're going to have secant squared of theta and plus secant squared of theta. So we're going to have 2 secant squared. So don't worry, I'm going to write everything out. So what do we got? We have secant squared minus 2 secant tangent and plus secant square of theta, whole thing over cosecant and secant minus tangent. Okay, now combining secant squared plus secant squared, we're going to have 2 secant squared. Oh my gosh, now what? All right, so okay, I feel stuck, so I'm going to try to convert everything in terms of sines and cosine, and let's just see where that's gonna go. So I'm gonna try this as 2 times secant squared is what? 1 over cosine squared, so I'm just gonna write it as over cosine square of theta, and then minus 2 times secant is 1 over cosine, and then tangent is sine over cosine, and whole thing over cosecant is 1 over sine, and here secant is 1 over cosine minus sine over cosine. Alrighty, so now what? Okay, so let's go with let me combine the numerators and denominators as much as I can. So what the heck do we have? So we got 2 over cosine squared, and then minus 2 sine of theta over cosine squared, and whole thing over 1 over sine of theta, and then maybe I could do 1 minus sine of theta, and whole thing over cosine of theta. Okay, now what? So let's try to combine the numerators and denominators together maybe. So this is gonna go to what? 2 minus 2 sine of theta, whole thing over cosine squared, and whole thing over, now if I multiply the denominator, I'm going to get 1 minus sine of theta because I'm multiplying this together, and then whole thing over sine cosine. Oh my goodness. All right, so let's bring this onto the next page. See, it was 2 minus 2 sine theta over cosine squared, 1 minus sine over sine cosine. Yup, that's exactly what we wanted to. Now that I completely forgot what I just wrote, let me just go back. Oh my gosh, whole thing over 1 minus sine over sine cosine. I hope I copied that one right. Alright, so now let's apply this business. A over B over C over D. This is A over B times D over C. Okay, so this is going to be 2 minus 2 sine of theta over cosine square of theta. And then here, multiplying here by sine of theta, cosine of theta, whole thing over 1 minus sine of theta. Okay, all right. So, let's factor the 2 out from the numerator. So here you're going to get 2, 1 minus sine of theta over cosine squared, multiplying here by sine cosine over 1 minus sine of theta. Oh look, we can cancel the 1 minus sine of theta. Kill. Alright, so then what do we have left over here? So this is 2 sine cosine over cosine squared. Now cosine squared is the same thing as cosine times cosine, right? So okay, so we can kill one of the cosines. Oh, look, I think we got it. So we have 2 times sine over cosine is tangent of theta. Is that what we wanted to prove? Let's go back. Prove. Goodness. So this is our right-hand side, and we're done. Alright, I must admit, I got little stumbled on this one, but hopefully you were able to follow it through. And great job, everyone. And I'm hoping that you're liking it so far. And if you have any questions about proving trig identities, please email me or just give me a call or just come see me anytime. All right, and I will talk to you soon. Great job, everyone. Bye.